Hi and welcome back. In this video, we're going to continue with our discussion of object-oriented programming by taking a look at how we can create a class. So recall that we're in the programming logic book right now. So when we look at how to define a class and the syntax that goes along with it, we will be using pseudocode. But understand that pseudocode or a compiled programming language such as Visual Basic or C#, regardless of the language you're using, you must define the class before you can use it. So a class serves as a blueprint. You can think of it as a blueprint from which any or as many objects of that type as you want to create. So in the previous video, we talked about a dog class. If we create a dog class, from that we can create many dog objects. But first we have to define the class. So the class definition contains a set of programming statements. And we're going to see that it's going to define the class in three ways. Every class has a name. Most classes have data that is not necessarily required, but most classes have data. And by the way, this data they're referring to is what we referred to as attributes, instance variables, and fields in the last video. And most classes also have some methods that can do a set of actions. So again, those are not required in a class, but most classes have them. So when you define that class, it doesn't actually create any objects, but after you create the class, you can create objects from it. That's called instantiating. So we'll see that, but first, let's talk a little bit about the creation of a class. Programmers call the classes they write, they call them user-defined types. They're also called programmer-defined types or abstract data types. Unfortunately, this chapter really slams it to us with terminology. But all of those really refer to the same thing, the fact that we can create our own type of data, such as dog. This is in contrast to the primitive data types we've been working with prior. In pseudocode, that was our num and our string, and when we were working with Visual Basic, it was our integer, our double, and our string, for example. So we're going to create a class, and it's going to utilize this concept of a black box. So a black box means once you create a class, other programs can use that class by creating an object, and it can interact with those methods of the object without ever knowing the details of how the steps are accomplished. So it's a feature of encapsulation. So that was something we touched upon in the last video. So let's look at how we can create our own user-defined type. So what we're looking at here is the definition of a class called employee, and the syntax applied is pseudocode. So starting from the top, we have class keyword and then the name of the class. Of course, at the end, we have the closer end class that shows where the definition of this class ends. And then up here at the top, we have some familiar features. We are declaring some variables. So these variables are the attributes and fields, instance variables. There's three different terms that have been used here, but they really mean the same thing, that relate to the kind of data that we're going to be storing about each employee object. So each employee will have a last name, each employee will have an hourly wage, and each employee will have a weekly pay. So it's the data that we store for an employee. Following that, this unit, and so forth going down, these are all methods, and hopefully for us, this looks very familiar too, because the previous unit was on creating such blocks of code to accomplish tasks. But what we'll find is a lot of times methods defined inside of a class have to do with the data of which they store. Now, not all the time, that's not necessarily true, but it frequently, we're going to have, for example, a method called setLastName that allows other blocks of code outside of this class, such as my console application, to set the last name of this object employee. So notice it has a void at the front. That means it doesn't return anything back to its caller. In other words, my console application that might use this employee class. The name of the procedure, set last name, and then in parentheses, remember this is a parameter that says it should receive a string piece of data, and we'll call it name. Name is used very quickly, it just turns around and uses it as the value to set this variable, this instance variable last name. So for example, if I called set last name on this on an object of type employee and I passed in Isabel, Isabel would then be used to update this variable last name. So the object's last name value would be Isabel. So you'll notice there's set last name, set hourly wage, and there's also a get last name and a get hourly wage. And this is kind of the converse, instead of pushing data to the object here, get last name doesn't receive any input, notice the empty parentheses, but instead it returns the value of the last name. So if our employee object's name had been Isabel, this would return Isabel. So it's going to look to that variable, that instance variable, and return its value. So the return type here of string reflects the fact that we're returning last name, which is of type string. So the same thing applies for get hourly wage and get weekly pay. Notice we don't have a set weekly pay, and the reason why is set weekly pay, weekly pay is updated by what we're going to call a work method called calculate weekly pay, because basically it's just a calculation of whatever the hourly wage is times 40. So we're not going to let my console application update that because the weekly pay is dependent upon the hourly wage. So you'll notice up here, set hourly wage, when a wage value is passed in, not only do we update hourly wage, but we call calculate weekly pay, which would come down here and execute this piece to ensure that weekly pay is updated accordingly. So this is an example of a class definition. If you're looking at this and thinking, wow, there's a lot there, there is, but the concepts that we're going to see again. And for this week, again, the expectation is just to understand, not necessarily to produce this type of code. So we have this class created, and once you create it, then you can utilize it. So where this is my class definition, what I'm going to flip to now is my program, my running program, my main, that's going to create an object of type employee. So notice in the declarations, this is where we've always declared variables. Instead of a variable of type int or string, num or string, my data type is actually employee. So once you create a class, it becomes a user-defined type from which you can create objects of that type. So I'm creating a variable with identifier my assistant, but of type employee. Now the interesting thing is once I do that, it immediately gives me access to that set of variables as well as the defined methods that you saw on the previous screen. So for example, I can set the last name of this object to Reynolds. I can set the hourly wage. Notice whenever I want to interact with, let me go back here for a second, set hourly wage, for example. Whenever I want to interact with this block of code, I can call it in my program, but I have to first prefix it with the object dot. So by putting the object name, my assistant, dot, I have access to, after that dot, any of the public methods, and we'll talk about what that means by public in a moment, any of the public methods in that class. So again, here I wanted to output my assistant makes, and then I wanted to print out how much money he or she makes per hour. So I knew that my object had that data. It stored the data in the hourly wage variable, which I could have access to via where are we here, get hourly wage. So this method here will return back the hourly wage. So I had to only refer to that object dot get hourly wage. At this point, the flow of control would leave this statement, jump over to that block of code called get hourly wage we just saw, execute the statements within, and return back the hourly wage value, which in this case would be $16.75. So because it returns it back, that's used in the final output that's concatenated here. My assistant makes $16.75 per hour. So employee had several methods. Two of the methods accept values from the outside world. Those are set last name and set hourly wage. Data is coming in. We're using it to update our own variables inside of this class. Three of the methods send data to the outside world when the outside world requests it. That's get last name, get hourly wage, and get weekly pay. And then we have the calculate weekly pay, which is neither a set nor a get. And that one does some work within the class. So you'll notice some patterns. They're set methods, also called mutator methods, that are used to set the value of a data field, also called instance variable or attribute or field within our class. Okay, so set last name is an example of that. We receive a name at runtime. Remember, this will actually hold a value like Isabel, and Isabel is then used to update the instance variable last name. So here, these three lines of code are what we saw in the class definition, but this line of code is what we would see inside a program that has created an object of type employee and called it my secretary. So object name dot gives us access to methods set last name, where we can pass in the value of what we want to set it to. So that was a simple one. Here we're showing a version of set hourly wage that includes data validation. So what that means is maybe we didn't want to just let any old programming code set our hourly wage to something that may not be valid, such as -10. That'd be an awful wage. So set hourly wage, maybe we want to build in some smarts so that we're going to check and make sure that it's not less than $14.50 and it's not greater than $70 an hour. So we know how to do that kind of thing. We can use an if statement. We're going to pass in the wage. And we have a couple constants, min wage, max wage, which we'll use as our fallbacks if this wage that's passed in is out of range. So we'll say if wage is less than $14.50, then set the hourly wage to the minimum. Else, if the wage is greater than max wage, which is $70, then set hourly wage to 70. Else, they stayed in the bounds that we were expecting, go ahead and set hourly wage to what was passed in. So this is just an example. Those numbers are kind of arbitrary, but the point is you can use your set methods to do any kind of data validation that supports the business logic of your program. And that's really the whole point of sets. Not only does it give you access so other programs can set the values as needed, it allows them to be set in a safe way that implements your business rules. Get methods are often called accessor methods, and the purpose is to return a value to the outside world. So here's the definition of get last name that we saw in the employee class. the data type string, so that means it returns string. Here's the name of the method. Empty parentheses because it doesn't have any parameters, nothing being passed in, and it simply returns the last name. So that was pretty simple. You know, sometimes gets can do a little more fancy things. For example, if you were saying get social security number and social security number was stored without dashes, but you wanted to display it with dashes, the set could go through and you know, add the dashes or format it in some other way before returning it back. So although we see a very simple get last name here, just understand that any programming code you would want to add in order to, you know, possibly format last name or return something in particular, you can do that in that method that gives you that control. And work methods, also called help methods, they basically perform tasks within in a class. We needed to update weekly pay every time hourly wage was updated, just so that it was correct, basically. So this was neither a get nor a set, but just something that we needed so that we could update data when hourly wage was updated to a different value. So here's an example. First of all, this is based on the class employee. So let me go back really quick. Here's the definition of class employee. If this is not created, the code we're about to see will never work. So this comes first. You create the class. Then we want to use the class. So here's my program, my main program. I want to create a variable of type employee. So here, in addition to my constants low and high, I actually create an object of type employee, and I call it my gardener. And I want to set my gardener's last name to green and set the hourly wage to a constant called low, which is $9. So I can do that. I can interact with this object and access the last name and hourly wage instance variables for this object. Remember, the way that I can do that is to use the appropriate set method and to prefix that with the object name dot. So I called it my gardener. So I have to say my gardener dot, and then what it is I'm trying to do. Set last name is the method I want to call. Green is the last name I want to use. And this is the same concept. We're just using hourly wage this time. I wanted to print out the weekly pay for my gardener. So again, output. Here we're concatenating a few strings along with a call to get weekly pay, which we know will go out and return the weekly pay for my gardener using the same strategy, object name dot, then the method get weekly pay. Remember, that's going to go back to our method get weekly pay defined an employee. Execute that code, return the weekly pay, and then finally glue all these pieces together. We then update the gardener's wage. We can set the hourly wage as well. So we update it to $14.65, and then we turn around and output the weekly pay again, just to show it changed. Okay, so in our output that we would see, we weren't actually asking the user for any information in this case. We just hard-coded the last name to green. So what we're seeing is just the two output statements, but it does show the weekly pay changed from $360 to $586. So the way that we would like our class to work is we don't want outside programs or any other methods to alter our class's data fields, i.e. instance variables, unless we have control over the process. So the set allows us to have that control. So by using a public set method, defining something as public access means that other programs and methods can use it. But we are going to define our data fields, also called instance variables, as private access, which means that outside programs or methods can't access them directly. So Again, either public or private, those are called access specifiers. And we place them at the front before our variables, as well as right before uh, our definition of each one of these methods. So here we see private on the same line as string last name. That means that we're defining, again, this is the employee class definition. We're defining an instance variable, also called field last name, of type string, and we're saying private. That means that these methods inside of the class can access this variable, but outside methods that are not part of the employee class cannot access them. So that means that my console application cannot update last name unless it uses the public set last name method to do so. So if these had been public, by the way, it would allow you to access the variable directly through the object name dot format. We could say my gardener dot last name equals Frank, for example. But that wouldn't be a good strategy. We want to instead define all our variables as private and our methods as public. These sets and gets will allow programs, such as this one, to set and get values as needed. So this is using the approach that we want. One comment is in this class definition, we did make calculate weekly pay private. And the reason why we made that private is there's no reason why an outside program should be calling this to update the weekly pay when the weekly pay should be an increment of our hourly wage. It should be hourly wage times 40. So it should be private. It shouldn't be accessible to outside classes or methods. It should be only accessible to this class, and it's called here. When we get a new hourly wage, we update that weekly pay. So what we're looking at here is a class diagram. I often talk to students, and this might get a little confusing because you might look at this and say, well, is this programming code I'm looking at? This is not programming code that you're looking at. So if you're trying to, draw a relationship between the syntax here and the syntax here, they're not the same thing. This is the code given. It is pseudocode, but it's still code of the employee class. This is not. This is just a kind of notation. It's called a class diagram. And the idea of a class diagram is to give a succinct way to describe a class, what data is part of that class, and what methods are part of the class. And it doesn't show any of the code inside the methods, it just shows what's available. Now, the idea here is that a company may want to have some sort of documentation of every class they have because they have so much programming code and they have 100 different class types, and they want to look put them all together in some sort of documentation so that they can quickly look up what all the classes they have and what they can do and what data they have. So that's the idea. This is just called a class diagram. And let me just walk you through the type of notation used. The top, of course, is just the name of your class. Very simple. And notice this diagram, by the way, has 3 distinct pieces. Okay, so if you're asked to create a class diagram, you would want to do the same thing. The second piece here is which fields, which instance variables are part of the employee class. So if you go back, we have a last name, an hourly wage, and weekly pay. Hourly wage and weekly pay were both nums, where last name was a string. So the way the notation works for class diagrams is that after the name of the instance variable, we have a colon and then the data type. So that's a little reversal of what we're accustomed to. So just something we need to be aware of. In addition, we have this little minus sign at the front of each line, and that's indicating that these are all private. So again, that's matching up to the fact that our class has a private access modifier in front of each one of those instance variables. So, as you might guess, this last portion of the class diagram deals with which methods are defined in this class. So once the class is declared, like we saw in the previous slide, we could be asked to create this class diagram and define what all the methods are. So here you see each one of their names, okay? And the plus sign is indicating that these are all public, so other classes' methods can use them. So again, you can see all of these are public. That's why we put the plus sign in that diagram, except for calculate weekly pay, which is private, okay? So after each method name, we have parentheses, and then we have the parameters. So again, kind of adapting this similar strategy of uh, you know, parameter name and then the type. We're doing the same thing here. So parameter name colon type. So that is string name, our parameter. So name colon string is how we would write that in a class diagram. The colon void at the end indicates that this particular method does not return anything back to its caller. So that's this part, the void, okay? This doesn't return anything back. Notice the empty return statement. It's a set last name. It's used to set the last name. It's not returning anything back. That's in contrast to these three gets. These get methods return last name, hourly wage, and weekly pay respectively. So we see the return type on these three are string num and num. So that's a class diagram. Again, it just gives you kind of a high-level view of what classes you have. In this case, we're looking at the employee class, what data it keeps in the employee class, and what methods it has. So sometimes programmers may ask the question, well, let's go back to that definition for a second of employee. Does it matter if I define last name first or weekly pay? And does it matter if the sets are first and then the gets, or can the gets be first, or should it go get set for last name, get set for hourly wage, and so forth? The short answer is it does not matter, but most programmers place data fields at the beginning of the class so they're easier to find. And if there's some sort of logical order, use it. So for example, if there's an ID number that is a unique identifier, like a primary key, for those of you familiar with databases, if there's some sort of identifier like that and it's important, I'd put that at the top. So, but basically you can organize a class's data fields and methods in any order. I just urge you to be consistent. So whatever strategy you employ when you create your class, the next time you create a class, your second class, is part of your solution, follow that same methodology. So maybe you do it alphabetically. You put all the methods in alphabetical order, or you have get and set method pairs, get last name, set last name, occurring one right after the other. Again, that's all fine and good. Just have some sort of logical order and basically stick with it when you create multiple classes.